Welcome to On Approach, your go-to podcast for expert insights in general aviation, proudly brought to you by AirMart. AirMart is a family-owned and operated aircraft brokerage that has been serving the aviation industry for over 50 years. We provide everything you need to make buying, leasing, or selling an aircraft simple and rewarding. Visit airmart.com to learn more. Our podcast discusses the latest trends, tips, and industry developments that matter most to pilots, aviation enthusiasts, and industry professionals. So buckle up, tune in, and get ready for a smooth descent into the exciting realm of On Approach.
Welcome back to another episode of On Approach, your podcast for everything general aviation. I'm your host, Kim Sutherland, Vice President of Development here at AirMart, and we've got an incredible lineup for you today. Today, we're going to talk about the world of aircraft engines in our episode, Powering the Skies, all about aircraft engines. I'm thrilled to be joined by an all-star panel of experts today. With us, we have Otthman Rasheed, owner of Triad Aviation based in North Carolina. He brings over 40 years of experience in engine overhauls and maintenance to us. With Otthman is Richard Diamond, his director of maintenance, who has been with Triad for nearly 20 years. Here at the table, we also have Austin Bourland, who is our director of maintenance at AirMart. He's been with us for about 10 years, and he keeps our fleet in tip-top shape, and he leads our maintenance team with his unparalleled expertise. And then we have Grant, of course. He's the president and director of sales and acquisitions at AirMart, and he brings his keen insight into the aviation market here today. Welcome, everyone.
Thank you.
So we're here today to explore everything from engine performance and maintenance best practices to the future of aircraft engines. So buckle up as we dive into what keeps us flying high. Our first question is going to be for you, Grant. As a pilot, why is it important to understand the engine under your cowling on more than just a throttle and mixture basis?
Excellent question. Every pilot is trained to have just a basic understanding of the power plant. So when we're trained as a pilot, we're trained about the fuel to air mixture ratios that are required. We're taught about the basic functionality of the piston stroke, the power stroke, the exhaust stroke. We're also taught about the simplicity of how the aircraft engine is different than a car engine because it has magnetos. So the magneto enables the aircraft engine to continue and will not fail if you lose all electrical power. So those are some of the basics that we're taught as a pilot. But over the years, when my father taught me how to fly, he really wanted me to understand more than just, hey, these basics that you're taught as a pilot from flight training. He wanted me to dive into more of how the carburetor works and how the difference between a carbureted engine and a fuel-injected engine. He wanted me to understand the exhaust system and complexities and problems that you could have if you did have something blocking your exhaust. So it's really important to spend some time with your mechanic and ask him some of those, in-depth questions, even where things are located. Because as a general pilot, we're not typically taking the cowling off and can't point out all the components and where they are. So if you get to a destination and you've got oil spewing from somewhere, to be able to not intelligently communicate with the mechanic of, hey, I've got an issue with this component, to be able to identify some of the components, that makes a huge difference. And the number one thing we want to have running when we're flying is that engine. So you want to make sure that you have an in-depth understanding of how that motor works beyond just the fuel and air mixtures. So spend some time with your mechanic, ask him some of the in-depth questions of, what would be something that would help me identify a stuck valve. So if you had an exhaust valve that gets stuck, because that can sometimes happen, and what's the best solution for that? Is it to power it up or reduce the power? So in those situations, if you've got a stuck valve, you don't want to be putting a lot of power to the engine. So things like that are very important details to understand as a pilot that could save your life in an emergency.
Okay. So in the world of pistons, there are two main engines from what I understand. You've got Continental and you've got Lycoming. So Otthman, I wanted to ask you, what are the main differences between these two engines?
Well, there's really, other than the brand, there's no difference in performance of the engines. They both good, reliable engines. Manufacturing-wise, they differ, in sometime in material that they use, both manufacturers. Everybody has it be a little different, but as far as the performance of the engine on both of them, they're just pretty much the same.
They have different TBO times, don't they?
Correct. They have different TPO time. What changes the TPO time? Most engines from Continental, they run right now around anywhere from 1900 to 2200 for a normally aspirated engine, and turbocharged normally they reduce that because the turbocharger by about 200 hours. Because the turbocharger puts a lot more pressure on the engine constantly on, so they'll reduce the TPO, and that goes for both manufacturers. Like Coleman, most of them are 2000 and above. Right now their new TPO is 2200 hours if everything is used as Lycomen parts. Continental TBOs, they follow the serial number. It's any engine after serial number, I think it's 1006 and above will have the additional 200 hours. So if it's 1700, like on a bearing, standard overhaul is 1700 hours. If you meet that serial number, then it's 1900 hours. That's on Continental engines. Lycomen is a little bit more than Continental, and of course, Lycomen engine costs a lot more than Continental engines.
Why is that?
I think that the best way to answer it is, I guess, material or cost. How many engines Continental makes versus Lycomen a year. So the more you make, the more the cost is become a little bit less. They're both dependable engines. There's thousands and thousands of them out there, and technically, they're both pretty good engines. Just depend on the airframe manufacturers when they design the aircraft and put out the bids, but Lycomen is a lot more expensive. I think Lycomen has the lion's share of the market in piston engine general aviation.
Interesting.
I think it's a lot more than Continental.
So,
Okay.
As far as numbers of engines out there, that number of application on different aircraft. Of course, the new Cessna, since Lycomen is owned by Textron, most of their engines are Lycomen engines, where 20 years ago they were pretty much a lot of them, or most of them are. There's quite a few Continental engines.
You had a question, Grant?
Yes. Otthman, can you comment on for us the differences in the camshaft location from a Continental to a Lycoming and any potential challenges with that?
Yeah, the camshaft is always a challenge in a piston engine aircraft that's normally aspirated. It's always all turbocharged. The Lycoming camshaft, almost 100% of them are on top of the engine. And Continentals, with the exception of the 76 series, like on the Cessna 172 and on our Seminoles, the camshaft, well, no, they all on the top, actually. I'll take that back. Except the Beechcraft Duke, the TIO 541s are on the bottom. The Continentals all are on the bottom, and they get a lot of oil, from splashing, and so they're more lubricated versus the Lycoming camshaft. And of course, Lycoming changed some design recently where they incorporated roller lifters. We have a problem with camshaft. It's just the nature of the beast, whether it's Lycoming or Continental. Continental has a lot of them. Sometimes so I would say, to be fair, they're about even with the camshaft issues between the two manufacturers.
Okay. Yes.
But the Lycoming mostly on top of the engine. Continentals is on the bottom, so they get a lot more oil than the Lycoming.
And did the roller tappets help a lot of that with the Lycoming engines coming out with that?
Roller tablets is fairly new, but I've seen some of them where the rollers fail. But not a large number, but you can count them on hand since they start with roller tablets. But they're definitely it's following the automotive industry basically. That's roller tablets. They have issue with the flat tablets. Has always been an issue, but I think they figured it out, and they're pretty good too.
Austin, I know you've been to engine school. I don't know if you've been to both Lycoming and Continental. Which one have you been to?
I've been to the Continental.
Okay.
Yeah.
And then you've changed probably 100 time that you've been with us. What do you see as the differences between Continental and Lycoming from, a mechanic's point of view?
They all have their pros and cons. They seem to favor, you see a lot more smaller Lycomings in the field with 172s and Archers, and they tend to be more popular. But then you'll see 550s and 520s were very popular whenever you get into Cirrus aircraft. Columbia used them, stuff like that. I would think it more so, like Otthman said, that they're comparable engines. They're both good brands, and every two things is going to have its pros and cons. But whenever a airframe manufacturer is considering which engine to go with, whether it's Lycoming or Continental, I would say it mainly probably comes down to two things, probably power and the installation, how it meshes with the airframe. I know that like Cirrus uses the 550 ends, and they has the cross flow intake system on it, and Continental likes the cross flow intake. It's very even, and it runs very good rather than the traditional B model engine that's got the intake underneath. And so it probably more so mainly varies with the manufacturer and what they're looking for in their installation, and where Lycoming, their starter might be in the front, whereas Continental, the starter's in the back. Continental might have a better cradle mount application for the engine, rather than you see a lot of Lycomings or hang mounts. I mean, it probably mainly varies with the manufacturer and how they're designing it and which manufacturer fits their kind of design. But
Okay.
both manufacturers of engines are good engines, and they've been flying around for a long time. So
Great. Okay. Are there favorite, like, are certain manufacturers, do they favor one or the other, or does it seem to change based on model and other considerations?
whether there's a rhyme or reason, I'm not sure of, but Cirrus has tended to stick with Continental for the SR22 model until the SR20 moved to the Lycoming. And Cessna tended to stick with the Lycoming engines in their higher performance airplanes. So whether there's a rhyme or reason to that, I don't know. I wouldn't know.
Textron owns Lycoming.
Do they?
There's
Do
your
they?
answer for
Did
Well,
that.
I was going to say that would be your answer,
Yeah.
right?
When
Yeah.
did they take over?
Othman, when did that happen? That acquisition? That was a while ago, wasn't it?
On the Lycoming engine on Cirrus's?
Oh no, on the acquisition. When did Textron acquire Lycoming engines?
Oh gosh, it's been at least 30 years.
Oh, wow.
That was back, I think, in the 90s.
About when they switched 182s.
Yeah,
from
yeah.
Continental to Lycoming.
Yeah,
Okay.
that's why.
Yeah.
That's
That might make
Textron
sense,
owns
yeah.
Lycoming. So there's your reason. There's no rhyme.
The Textron owns Lycoming, owns Cessna, they own Beechcraft, Bell Helicopter. They own Textron is a huge company in aviation. As far
Yes.
as,
So money is the
Yeah,
reason. It all
Yes,
comes down
there's
to
always
money.
there's always money behind it. So
It
yeah,
always comes
back
down to
in
money.
back in the 80s, the 182 had the Continental engine, but when they did the restart
Yep.
in 1997, Textron owned Lycoming, so all of the Cessnas being built were going to have Lycoming engines.
Yeah.
Okay. Well, that makes sense. All right.
Yeah.
I have another question for Othman. What three things do you wish every pilot or aircraft owner would just know cold about their airplane's engine? Like, without a shadow of a doubt, if you asked them the status of three different things, what should they know?
I'm gonna give that question to Richard to answer.
Okay,
I
great.
think top things they should know is the how to operate it properly per their flight manual, but they should know proper leaning and then proper maintenance and operation, um, primarily to keep the corrosion down. But temperatures, I would say, is really top priority there while operating for best cylinder care to get the most life out of them.
Yeah, me and Richard had a really lengthy discussion about leaning and running your engine. Last week was it? Talking about running lean a peak and everything, and burning your exhaust
Right.
valves and that sort of
We're
thing.
not a big fan of Lena Peak for
Yeah,
sure. I know a lot of
that's what Richard said.
Hotly topic.
A hot
Yes.
temperature is a hotly debated topic.
Lean a peak.
Oh, lean a
is
peak.
a big.
Well, yeah, let's talk about that for a minute.
Oh, man.
Let's talk about lean and peak.
Well, my opinion of it is, it's good, and when it's appropriate. So you look at a new Cirrus, it's set up so that you take off and you're leaning. Your carrot is at lean of peak. That's the way it's made to be ran. But when it comes to 500 hours down the road, when you might have a clogged fuel injector, you might have some sort of intake leak or something like that, and your temperatures are running uneven, and the pilot's just trying to run at lean of peak, or running it to the carrot without realizing that one EGT is higher than the other or whatever, where an adjustment would need to be made because of time on the engine or something needs service. So it's okay, in my opinion, when it's appropriate, but you need to be able to recognize whenever you need to either one, get maintenance, or two, run it rich of peak until you can, because that's where things can get it. Are designed so that if you do it in accordance with a procedure, everything's fine as long as everything's fine. But when something breaks, you need to be able to recognize that, hey, this isn't right. I need to operate the engine a little differently.
Lean a peak. Everything has to be perfect. I mean, you've got to have perfect ignition system, perfect EGTs, perfect CHTs. But yeah, I'm more Othman's camp of not lean a peak, because fuel is lubrication, is everything I've always heard. So, but Othman, you're the expert on motors, so you take the lead.
Well, one thing, sum it in one word, is maintenance.
Okay.
Follow the the 50 hours, the 100 hours, especially on Continental engines. A lot of people do not do the fuel system setup, and it should be done either once a year or every 100 hours, because they do change, and that would go a long way in helping the engine operate properly as far as fuel and leaning and mixture. So I stress that to everybody, mainly on all Continental engines that are fuel injected. If you do that, then your engine will last to TPO. A lot of people I talk to in the field, they don't even know that you're supposed to do that, which is a requirement by Continental maintenance manual, And Richard goes a lot through that, does a lot of that setting up, and it's a procedure that you really need to know what to do.
Yep, it's a process.
And I can let Richard speak to that if you want.
Yeah, go ahead, Richard.
Yeah, I see. Yes, I see that problem all the time. A lot of people, they wait till there's a big problem with their fuel system. They call up and say, "I need a fuel setup." I kind of ask them what the issue is. Do you need a fuel setup or a fuel troubleshoot? And most of the time, it's a fuel troubleshoot. They've been let go too long. It is important. These engines need fuel, and they've got to have the fuel. It's the way the manufacturers, I've had long conversations with them as far as running lean a peak, but it's important to have the fuel system running at peak on these Continentals and have the fuel systems adjusted properly so that you can go lean a peak accurately, and it does need to be leaned accurately, or you'd cause damage. And we'll see that too. So it's something very important. And there is a lot of maintenance shops that are unaware of how to properly do it, or even see that it gets done. Like I say, I see it a lot. I get a lot of calls, and a lot of them get the aircraft here so we can do a fuel setup. But it plays a huge part, especially in a Continental.
And one more thing, and then I'm shifting off the engine to the prop, but it's part of the engine. It's very important to do the dynamic balance in the same manner every annual.
Really?
To check the dynamic balance, because they both connected. If you have vibration, then that transmits into the engine, there's a lot of extra wear and tear. So these, the fuel system setup and the dynamic balance, which just goes to the heart of the maintenance. Yeah, as far as the engine longevity, will make a huge difference.
Okay. That's great.
Yeah.
Those are great tidbits, great pieces. Thank you.
Good to know. Well, let's move on to overhauls and upgrades and different STCs. Otthman, can you tell us about the different types of engine overhauls and when an owner would choose one over another?
It all boils down to you got to follow that going procedures and your own standard. And everything has to meet the requirement of the overhaul manual. And the way we do our engines, our own procedures, we replace quite a few. I would say 70% or 80% of the engine as parts are replaced. And we only, on our overhauls, very rarely we use overhauls. Only new cylinders, whether it's Lycoming or Continental. And knock on the wood, we don't have issue with them. And again, the fuel system, the ignition system, all that is replaced or overhauled to meet specs, whether it's Lycoming or Continental. Whether other shops, there's a lot of good quality shops there, and there's some that are not, without mentioning them. But sometimes if it's too good to be true, believe me, it is. The price is huge difference between our price and other engine shop. There's a few, that are good. We all around, within a few thousand difference. It depends on the geography and where you're located at and what kind of, cost of living. Like in New York is a lot more than here, or in California or Colorado. That makes a difference in the price. But the quality of work, if they use the top quality that's available in the market, whether it's genuine Lycoming or Continental. For us, Lycoming, we have 100% Lycoming parts on all our engine. Same thing with Continental, but sometimes we use some aluminum cylinders. Customers prefer those. But it depends, what you change, what you replace. There's a lot of cost involved into that, and procedures that you have to follow that dictate the price. Of course, factory reman or overhauled or Continental factory rebuild or new, there's absolutely no difference. They follow the same procedures that we do.
Okay. Do you have anything to add to
No
that?
corner cutting.
Yeah, no corner cutting is what he said.
Okay.
You follow the manual, and that's the way it is. And like he said, there's if it's too good to be true.
We go beyond the manual. We go beyond the manual too. We have our own standards too.
Yep. So above.
Yeah,
above and beyond.
don't you take your you measure your limitations on your overhauls to factory limitations? Or am I misremembering that? Yeah. So he measures to the same standard that a factory overhaul does when he does
Yeah,
overhauls.
you do measurements, you do visual, you do non-destructive testing. There's a lot of things that you have to do
Yeah.
that's involved in the engine. And like every piece, when we go into the engine, you got hundreds of pieces. Every piece gets inspected, and if it does not meet our standard or the factory manual, it's automatic replacement.
And we can attest to his high standards and high quality because we have literally bought
Yes.
hundreds of engines from Triad. AirMart has
Hundreds.
literally bought hundreds of motors. So,
Correct.
yes,
Yeah.
the best.
We do on average, between 400 and 500 engines a year. So
Wow.
Yeah,
we stay pretty busy.
it's a lot.
Yeah, that is a lot. Okay. Well, let's talk about some upgrades. Othman, what are some popular upgrades that can improve engine or reliability?
There's a few STCs out there, and I'll pick the first one, like turbo normalize, no matter who does it. The advantage of turbo normalize is, you can fly higher and maintain manifold pressure at, above 12, 14,000 feet. And that's the advantage of a turbo normalizer. Might give you a little bit more power. There are others that the camshaft on the Continental engine that which is a good concept that gives you an extra 3%. So it's a 300 horsepower engine. Will be 310 horsepower. Also, you got on Bonanzas and some other aircraft, you get STCs for exhaust flow. Flow makes a big difference. Smooth going in and smooth going out. There's no turbulence. That give you additional anywhere from 5 to 20 horsepower increase. So these things we've done here, and we know they work. Others will be like Roman engines. They have some STCs out there on a smaller scale, like a 172, the older 172, that you can put an STC on it to increase the horsepower by about 10 horsepower, which is a different, just changing the piston and single part number. They're all of them the same now, but they used to be different part numbers. But basically, these are the things that are available. Really, the manufacturer, when they put up the specs from the airframe manufacturer, the engine manufacturers, they get the top parts of the engine. There's some improvement, of course, in the field. Always somebody will come up with some ideas, and most of them are good ideas. Whether it's turbo normalized or upgraded camshaft or horsepower increased by changing the piston compression ratio. Other than that, really, it's a simple engine. There's not much you can do with it, and also now there's people putting out electronic ignition now, and we're not too keen on that electronic ignition, but making their own, I recommend those for put one on the left side, and I think it's a good concept. But you have to have redundancy on the other side.
Yeah,
with the
Othman,
standard.
I've had my opinion changed on electronic ignition. I used to be in the same
Yeah.
boat where I didn't like it. I was kind of old school. Mags have worked for a long time. But
Well, mag is for sure is a lot. As far as if you talk to electronic ignition, they the advantage is that you have to run to TBO with the maintenance free.
yeah,
But as you know, it has electronic equipment in it. So things can go wrong. That's why some people will have two electronic magneto, but then you have to add a battery to that because that's the
Redundant
redundant power supply.
Yeah.
Separate power, and which involves a lot. So one is enough, and then it definitely helps the performance. And Richard, do you have anything to add to that?
No, it does help with the ignition, and firing. Starting to show some good results with that. Like I say, it's good that Lycoming is starting to build their own. I think there's some sort of maybe partnership with Surefire. But
Yeah, and then they went beyond on their mags,
yeah, a little less complicated, but seems to be a real good upgrade at this point.
Ignition, which I'm with you. I don't like something relying on something else to function, like a battery or whatever. You lose electrical power because you lose your ignition source, whereas magnetos, you lose electrical power, your engine's going to still sit up there and run. You guys, where putting one on's okay, just because I don't really, 100% trust them yet. But where they really shine is when it comes to spark advance. Having a variable spark advance is really big because, as you guys know, right now, most engines and airplanes have a fixed spark advance. So when you're at idle, that's not the most ideal spark advance. And also, whenever you climb and you have thinner air, the spark advance needs to change as well. And I forgot the brand of the Magneto. I wish I could give them a shout out with it. But at the last IA seminar, they had a speaker there who went into depth on it. And they measure manifold pressure and everything like that whenever whenever you climb up, and it'll change the spark advance based off of manifold pressure, and you're always getting the spark at the exact time that you're supposed to. And so that aspect of it is really good and can help your engine over time. And even my question was, if you had one mag that had variable spark advance and then the other mag didn't, would that mess with it? And what they said is no, because it will always be equal to or better than the other magneto. So even though you have one that's firing at a different time, it's not going to harm it because it's always equal to or better. But that's what I see as a huge benefit to the electronic ignition is the spark advance, and it's a very interesting topic. But until they become more common practice, I'd like to at least have one magneto on there still.
Yeah, for now.
Magnetos, redundancy, and running with that. If you lose power, which a lot of aircraft sometimes they do lose power.
Oh yeah.
It's a solid technology, and then the electronic mags definitely there's improvement to in performance.
What is the latest technology for aircraft engines right now? Things that are evolving and emerging as new technologies, and which manufacturers do you think are leading the way?